Hello guys. Until this video we learned two methods in linear algebra which we can use in order to find solutions for our linear systems, and we will start a new topic in linear algebra in this video. But before starting, I decided to make a video to teach you a few terms you should know about linear systems. I think you should know them in order to understand better the coming lectures, the coming videos. And I want to start with consistency and inconsistency. Here I wrote a definition for these two terms. Inconsistent: if a linear system has no solution, we can say it is inconsistent. This means if you try to find solutions for a linear system and you couldn't find any solution, if you have no solution, you can say it is inconsistent. And another term is consistent: if a linear system has a unique solution or infinitely many solutions, we can say it is consistent. This means if you can't find solutions for your linear system, it is consistent. And here I wrote unique solution and infinitely many solutions. This means if your linear system has unique solutions, this means only you can put a determined numbers instead of your unknowns. For example, your solutions will be like that. They are numbers and you couldn't change them. It says you x2. You couldn't put 3 or another number to change them. They are always same and they are unique. For x only you can put 2 and y for z 5. This means this linear system has unique solution because, as you can see, the unknowns has unique numbers. And another situation is infinitely many solutions. For example, you try to solve a linear system using Gauss-Jordan method and you reached these solutions. We said x equal 2z and y equal 3z and z equal 5k. Here you can put numbers. It doesn't matter which number. You can choose a number which you want to choose and put instead of k, and according to that number you can change the values of x, y, z. They can change and there is no any restriction for you. For example, if you put instead of k1, z will be 5, and z has changed because of this reason. Y and x will change because they depend on z here, their values. And it is possible to understand a linear system, the type of linear system, without solving it completely. If you find your upper triangular matrix, you can interpret that upper triangular matrix and you can predict your solutions. You can understand whether you will have unique solution or infinitely many solution. Right now I will try to explain you how to understand this from upper triangular matrix. Let's suppose we have, I will give the example with numbers because it is better. I think it will be more easy for you to understand. I am writing these numbers randomly only to give an example. And here we have numbers. Here, look at, we have upper triangular matrix because the terms are 0. Only you need to look the third row to predict the kind of this linear system. If you have a number which is not 0 here, you can call this linear system has unique solution. After you solve this upper triangular matrix, you will find a unique solution. As I wrote here, you will find numbers and they are constants. You can't change them. And also we have another situation for this. Let's suppose your whole terms 0 here and also the answer 0. And you have numbers here. I don't know the numbers. They are not important. It doesn't matter which numbers you have. Only you will look the third row again. Not the third row. If you have 4 row, it will be fourth row. You need to look the last row. In the last row, if your whole unknowns are 0 and also the answer is 0, directly you can predict that you will have infinitely many solutions. Infinitely many solutions. Infinitely many solutions. This means your answers will be like that and you can change them. Already I talked about this in this video. And another situation is that, let's suppose again whole element 0 in the last row. And we have a number here which is not 0. Let's say it is 8. I gave an example. If whole elements are 0 and you have a number which is not 0 here in the answer, you can say it has no solution. Because already it doesn't make any sense. Look at here, you have no any element. All of them 0. And you should have 0 here, but we have a number. You can understand that you won't find any solution for this linear system after making the required operations. And I want to give an example for infinitely many solutions. Let's try to solve with numbers. I will write numbers here randomly. Here should be 0. When you find this upper triangular matrix, as I said, you should understand it has infinitely many solutions. And I will show the reason for that. When you look at the third row, you will start the solution with the third row, the last row. You have nothing here, but you can say, we know x, y, and z. They are x, y, and z. You can say z is k. I only gave a value. And when you replace this k here, you will see that 5y and z, we said it is k. We have 6z. This means k equal 5. And as you see here, the y will be 5 minus 6k over 5. And again it depends on the k, and you are able to change this k. You have no any restriction. I can say it is 1. Again it will satisfy our answer. And you can always change it. For example, I can say it is 2, 3, 4. I am free to do that because of the last row. And when you try to solve x, again it will be depend on k. I think you understood what I meant by saying infinitely many solutions. You can change the solutions, but here again I will give an example for unique solution. Let's suppose we have something like that. I said, when you see this upper triangular matrix and here we have a number which is not 0, it is unique solution. Look at here, we have only one z and it says it is 6. Already we found our z and it is a constant number. You can't change it. It is unique. And when you replace it here, it will be 5y plus 6z equal 5. When you write 6 instead of z here, it will be 36. And when you make the operations, you will find y. Again, it is a constant and it is a number which can't be changed. For this reason, we say this linear system has unique solution, and already I say the situation of no solution because it doesn't make any sense. And they are the type of linear systems according to their solutions. Before starting new topics, I thought it is useful for you to know these terms. And this video is over right now. I will start a new topic in next video. See you in the next videos.